Right. So let's say if we have 2 over 35, and this is a fraction, and you know 35 is equals to 5 times 7. So let's say I want to split the 5 and the 7, and I want to write it in terms of a over 5 plus b over 7. So what should I do here? So a very easy technique we can do is we can just 2 over 35 equals a over 5 plus b over 7. So we don't know a or b is, and we're gonna solve it. And there's a lot of methods of solving it, including substitution, even even elimination, and yeah. So I'm gonna guide you step by step. So we have 2, so we're gonna multiply both sides by 35. So this multiplied by 35, and this will be multiplied by 35. So what we have here is 2 is equals to, so this is 5 times 7, and this 5 will cancel out with this 5, leaving only 7, and this 7 will cancel out this 7, leaving only 5. So this is actually 7a plus 5b. So now we're gonna do a thing, and alright, here's the thing. I'm gonna let x equal 5. So I'm gonna erase this first. So I'm going to let x equals to 5. So now here, what will be our new equation be? So now we have 2 over x times x plus 2, because 7 is 5 plus 2. So we need to break it into a over x plus b over x plus 2. So now, by letting x equals to 5, we need to split our fractions in this form. So now, at the same time, we multiply 35, which is 5 times 7 on both sides. We can multiply by 35, and this multiplied by 35. But what's 35? Since x equal to 5, 5 times 7 means x multiplied by x plus 2. So we're basically multiplying x plus 2 on both sides. We're basically multiplying x times x plus 2 on both sides. So we multiply x and x plus 2 on both sides. And this will be equals to a over x plus b over x plus 2, x plus x and x plus 2. So to solve for a and b, this will be similar, not equal. So this x will cancel out with this x, and we will left us with a times x plus 2. And this x plus 2 will cancel out with this, and we will left us with x, so times bx. So now, since now x is now a variable, even though we have defined it into 5, but to solve for a and b, we must change the variable. So we need to let x equal 0. Why? Because this will cancel out this term. This term will be 0, and we can solve for a. So since x equals 0, 2 will be equal to a times 0 plus 2 multiplied by b times 0. And this is 2 equals to 2a plus 0. So thus a equals to 1. And from here, we can plug our values to v, which is the previous thing we have done before. So we know that when we have 2 over 35 equals to a over 5 plus b over 7, then we have 2 equals to 7a plus 5b. And from here we can solve for b by simply doing 7 plus 5b. So thus b equals to -1. So another way to solve for b instead of this is we use the previous function. So now we have 2 equals, I'm going to write the same function over here. I'm writing the same thing over here. So now we're solving for b. So we have 2 equals to a times x plus 2 minus bx. But in this case, since we're solving for b, we're not going to let x equal 0. We're going to let this term equals to 0. So how can we let a times x plus 2 equals 0? As we know, this term must be 0 because a is a constant. So if x plus 2 equals to 0, then x must be equal to -2. So we're going to let x equals -2. So we're going to substitute into here. So we have 2 equals to -2 plus 2a plus b times -2. So this is equal to 0. This will be 0. And we have 2 equals -2b, thus b equals -1. So as you can see, we did the same thing. It's the same thing over here. So now since we solve for a and b, we have successfully solved for a and b. Therefore we can say that 2 over 35 is equals to a over 5 plus b over 7. Since a equals to 1, so this will be equal to 1 over 5. And since b is -1, this will be equal to -1 over 7. So now let's test this. So to solve this, we multiply both sides by 35. So this will be 7 times 1 minus 5 times 1, and this will be the same as 7 times 5. So as you can see, 7 minus 5 is 2, which gets the same result over here. So we have solved for, so now we are using partial fractions to solve this question. So I'm going to give another example. But this time, since you know what it feels like when it's a fraction, now we're going to solve actual problems. So now, let's say we have 1 over 1 over x plus 1 and x minus 1. And now I want to split this thing, and this will be equals. I want to make this similar to a over x plus 1 plus b over x minus 1. So now what should we do? So the first thing is we're going to multiply both sides by this denominator. So we do the same thing over here. So we have 1 is similar to a times x plus 1, x minus 1 over x plus 1 plus b times x plus 1, x minus 1 over x minus 1. So we know that this term and this one cancel out, and this term and this one cancel out. So therefore 1 will be equals to a times x minus 1 plus b times x plus 1. So how are we going to solve this? So the first thing I'm going to do is substitution. So by using substitution method, so I'm going to let x equals to 1. So by doing x equals 1, we can make this term 0. So we're going to make this term 0. So 1 will be equal to a times x, a times 1 minus 1 plus b times negative 1 plus 1. So therefore this a is going to cancel, it becomes 0, and b will be similar, and 1 will be similar to 2b. So b equals to 1 over 2. So now with this, we're going to solve for a, and by knowing b is equal to negative 1 over 2, we're just going to substitute, do another substitution. X equals to negative 1, and this will cancel out this will cancel out this term and makes this term 0. So we have 1 is similar to a times negative 1 minus 1 plus b negative 1 plus 1 and now this b will be equal to 0. Therefore 1 is equal to negative 2a, a equals to negative half. And now since we have a and b, therefore 1 over x plus 1, x minus 1 will be equals to negative 1 over 2, wait, 1 right, this also can, negative 1 over 2 x plus 1 plus 1 over 2 x minus 1. And after we write, we can write this in terms of 1 over 2 times x plus 1, minus 1, minus 1 over 2 times x plus 1. Yeah. So we solve it, we basically just solve it, and we split the partial fraction into half. So what's the usage of this? Well, it'll allow us to make integration much more easier, and it can also help us solve some problems. So what I'm going to do now is I'm going to do a general form of this. So let's say we have 1 over x minus a times x minus b, and I want to write it in terms of I don't know, so maybe k or p over x minus a times plus q over x minus b. So you see, a and b could be any integer or any number. So a and b can be any number as long as it's real or complex. I don't know, it can be anything. Yeah, but mostly we're just gonna focus on reals. So now, So in most cases, this probably might not be a, so can be k here. So I'm gonna add this into the case too. So the first thing, we're gonna factorize k out. So this will now look like this: x minus b. And since we factorize k out, we're gonna focus on this. Let's focus on this. And now this will be equals, will be similar to, alright, you know what, let's make it 1 for now. So this will be equals to p over q, and I'm gonna write it again. I'll just copy the same thing again. Alright, so the first thing you do is gonna multiply both sides by x minus a, x minus b. So we have p times x minus a, x minus b over x minus a, and then plus q over x minus a times x minus b over x minus b. And now this and that will cancel out, this and that will cancel out. So now 1 will be equals to p times x minus b plus q times x minus a. So the same thing, we're gonna let x equals to b. So now everything will change. So 1 will be similar to p times b minus b plus q times b minus a. So since d is equal to 0, so now we have q equals to 1 over b minus a. So really good thing. The same thing, we're gonna let x equal to a to cancel out the a term. So we have 1 is similar to p times a minus b plus q times a minus a. So now this term will be equal to 0, and then we have p is equals to 1 over a minus b, or negative 1 over b minus a. So since we have p and q as the same term, so I'm going to write it down. So we have 1, so we have 1 over x minus a times x minus b will be equals to p, which is negative 1 over b minus a, so negative 1 over b minus a all over x minus a, plus b, which is 1 over b minus a, the positive, over x minus b. And I'm gonna factorize a and b out. I'm gonna factorize this thing out. So this will be factorized. So therefore, we have this is also equals to 1 over b minus a. So now we have a negative 1 over x minus a plus 1 over x minus b. So now this is equals to 1 over b minus a times 1 over x minus b minus 1 over x minus a. And that is equals to 1 over x minus a times x minus b. And there you have it. This is the general form for all things, for all a and b's. So I'm gonna write, so if let's say x minus 3, x plus 9, so what's b minus a? So b is negative 9 and a is 3, so this will be equals to 1 over negative 9 minus 3, and then x minus b, which is 1 over x plus 9, and then minus x minus a, which is just 3, so 1 over x minus 3. So this will result in, so negative 9 minus 3 will be negative 12. So this will be, so this term will be negative, and it will become negative 1 over 12 x plus 9 plus, I mean this is plus actually, wait, oh yeah, this is negative, my bad. So this is minus 1 over x minus 3, and we can flip the thing. We can flip the, since this negative is going to multiply, and we can flip the order inside this. So now we have 1, so this will be equals to 1 over 12 times x minus 3 minus 1 over 12 times x plus 9, and this should be correct. Yeah, it's correct. So since all of the work we done, I only show you one method. And what about the second? The second would be comparison. So what's the comparison method? So what's the comparison method? Well, let's try it in one question. So let's say we have x plus 1 over x squared plus 1 and x minus 1. So alright, let's try another method. This will be, this is not the basics, so I'm still gonna use the comparison method. Yeah, much better. So now I'm gonna split it into a times x minus 1 plus b over x minus 2. So the first thing we do is gonna multiply both sides by this thing over here. So right now we have x minus 3 will be similar to a times x minus 2 plus b times x minus 1. Why? Because if you multiply both sides by the denominator, this x minus 1 will cancel with that, and it will left this x plus 2, and this will be occurs the same with this. So now I'm going to use the comparison method. So what I'm going to compare, so let's first express this in terms of x and constant. So this is pretty much scattered. So x minus 3 will be similar to ax plus bx minus 2a plus, minus, this is also minus b. So this x I'm going to factorize. So x minus 3 equals, similar to a plus b x minus or plus 2a minus b. Yeah. So you see this x is equal to this. We're going to compare x with a plus b. So I'm going to compare x. I'm going to compare x with a plus b times x. Yeah, since these are similar, so we're just gonna let x is similar to a plus b x. So we can just cancel out the x, and we know that 1 is equal to a plus b. So there's b equals to 1 minus a. And what we're gonna do with this thing, so don't forget that we still have a constant term here. So now I'm gonna compare the constant. So now we compare -3 with what? With -2a plus b, 2a minus b. So now we have, oh my god. Okay, so we have right, I'm gonna move this to a new slide. Right, good. So now we're gonna compare -3 with -2a plus b. So -3 equals to -2a minus b. So the first thing I'm going to cancel the negative because it's very annoying to write. So 3 equals to 2a plus b. And now we have a simultaneous equation. So where is our first equation? We have this. This will be our first equation. This will be our second. So now I'm going to substitute. Just like solving two substitute. Alright. So it's like solving linear. It's like solving linear simultaneous equations in two variables. So substitute 1 into 2. So we have b equal 1 minus a. So 3 will be equals to 2a plus 1 minus a. So 2a minus a will be a. So a will be equals to 2. Right? Yeah, a plus 1 equals to 3. So a equals to 2. So from this we can also solve for b. And since b equals to 1 minus a, b will be also equal to -1. It's like 1 minus 2. So b will be -1. Alright. So what's our question again? Oh shit. Where's the question? Let me find the question real quick. Oh, right here. Damn. Alright, so we have this thing. Alright, so now we know, so what we know is we found out that a equals to 1. So since a equals to 2 and b equals to -1, which is right here, I'm gonna highlight it. And we can finally know that x minus 3 over x minus 1 times x minus 2 will finally equals to 2 over x minus 1 minus 1 over x minus 2, which is perfect. Yeah, this is perfect. So I hope you understand what I'm talking about, and if you're confused, you can write in the comments and let me know. So I'll see you next video. So in here we learn math by our instincts. We don't memorize formulas. We just go with instincts, and because it's the most powerful thing ever. So goodbye.